Welcome to a short product introduction on eccentric disk pumps. I work with Integral Process Equipment. My name is Stephanie Stevenson, and I wanted to share with you just how eccentric disk pumps work and when to consider them in your applications, what their advantages are, and help you think about whether or not these advantages could be useful in particular applications within your processes. So an eccentric disk pump is actually a positive displacement type pump. How it works is by trapping a fixed volume and forcing that through the pump and out through the discharge. So this allows you to have a nice, even control of the flow. You can basically control the RPMs if you want to dose a specific amount. So that can be very useful in many applications. Looking at how these pumps work, there's two main parts. There's a stationary cylinder and there is a moving disc. So that moving disc there will sit right inside that yellow stationary cylinder and it will rotate around, chasing the fluid. It'll basically create an inner chamber and it will create an outer chamber, and it will force the product along and push it through the pump. Looking at this put together, you can now see the blue disc sitting inside the stationary disc, and it will suck product in from the back and push it out through the front. So I have a little video here. This shows you the moving disc and shows you how it creates these two chambers. So the first chamber you'll see is actually, it'll come there in green. That's the outer chamber. So that moving disc just creates that chamber, chase it around, and then you can see the blue, and that's the inner chamber. So those two chambers are a really important concept about this pump, because those two chambers actually balance the flow as well, which we'll talk about in a minute. So the advantages. So what possible reasons would you have for thinking about this pump or choosing it over a different technology? The first one is it can save money. It can recover product from the lines. It can push all of your product out of the lines, and this can save a significant amount of money, especially over time. It is a self-priming pump. So if you have a tank or you have a tote or something and you need the pump to suck that product in on its own, this pump can work very well for you. It's pulsation free, so we'll talk about that in a little more detail, and this has to do with the inner chamber and outer chamber pumping at different times and balancing the flow so that you do get a nice pulsation free flow. It's very low shear, and we'll look at that. It has a long service life, so it's actually has some built-in wear compensation, and I'll show you how that works. So this can last for a really long time and not have any change in the volume or change in its ability to self-prime or push the lines clear. There is also an easy clean system. So if you are in the pharmaceutical or hygienic industries, you can CIP this, and it does have all the approvals and things that you would be looking for. So the first key advantage, self-priming, we'll take a look at that. This pump is actually able to create a vacuum down to minus 13.7 psi, and this sucks all the product up in through the pump and then pushes it out. So along the same thought line here, the ability of this pump to run dry is really important. And what happens once you've pulled all that product through and you start pulling air is you can actually continue to run this pump dry, and it will compress that air and it'll push it down your lines. It's actually able to create pressures up to about 72 psi, and this will push the valuable products from your lines. So this one feature is actually the one that we tend to see customers focusing on or thinking about, because it does have that dollar ROI for them. It does seem to influence decision making on technology choices. So this will help as well if you are currently doing a water push or pigging the lines to recover product. This pump itself can eliminate having to do those processes. Looking now at the inner and outer chamber flow rates, so they kind of happen at alternate times, the inner and outer chambers. and they will balance themselves out, and you can see that in the graph there. So they're simulating. The yellow is simulating, excuse me, the yellow is simulating the inner chamber, the red, the outer chamber, and then the green is showing the combined flow. So this is really nice. Let's say you have an application where you want to put a nice even line of glue or an even line of icing on some donuts. This will allow you to create that nice even flow and to accomplish that. Now, taking a quick look at the shear rate for these pumps, they do operate very slowly, and I'm comparing it against a low pump just because low pumps tend to be chosen when you do want low shear. So this is showing this is just, one step even above a low pump. It does have a nice low flow rate and will not shear your product on you. Another key advantage is the long service life. This pump has two built-in springs, and what they do is they provide radial and axial contact, and this allows over time you don't have to worry about any wear on the pump or any reduction in its ability to self-prime or push the product through because these springs are always doing a compensation there. Looking at cleaning applications, if you're in the hygienic industry, you might be familiar with the fact that some pumps need a CIP bypass. And the reason they need that is because the flow rate going through the pump would be too low to properly clean the downstream processes. So in this particular pump, you actually don't have that issue. You can stop the pump and put the CIP flow through it in reverse, and this will go through and it will clean all of the chambers. It's designed to be cleaned, and the CIP flow will actually push against those springs in a reverse manner, and they will actually open up any of the contact surfaces to allow the pumps to be fully cleaned. So these pumps, the hygienic versions, do have 3A and E-Hedge and all the approvals needed for use in food applications. Just looking lastly at a couple of applications, we do have a lot in the hygienic field. So thicker products, more expensive products, sauces, yogurts, cosmetics, ointments and creams. And then in non-hygienic applications, we tend to see the products in glues or thicker inks, more expensive products, or things that you don't want them to remain in the line because they may clog them. So yeah, thank you very much for your time. I hope you learned something about the eccentric disc pumps, and I've put our website there, so integralpx.com. We do have an office in Montreal and in Burlington, and we generally help customers with pumping and mixing, blending, valves, and all sorts of process control applications. My name's Stephanie Stevenson, and my contact info is there as well. And don't hesitate to reach out should you have any questions or want some further information. Thank you very much. Have a great day.